Hey, this is Mr. Simmons with Electric Charge. In this section, our objectives are describe how electric charges exert forces on each other, compare the strengths of electric and gravitational forces, distinguish between conductors and insulators, and explain how objects become electrically charged. So our vocab, we have static electricity, law of conservation of charge, conductor, insulator, charging by contact, and charging by induction. So one thing we want to think about are what particles is the atom made of and what are their charges? Positive and negative charges. Atoms contain particles called protons, neutrons, and electrons. Protons are positive, electrons are negative, and neutrons are neutral. We can find protons and neutrons in the nucleus of the atom. Electrons are found outside the atom. Positive and negative charge. Electrons can leave the atom, protons cannot. The positive charge on protons are equal and opposite to the negative charge on the electrons. Objects that do not have a charge are said to be electrically neutral. So if we look at the periodic table, protons and electrons are equal in the periodic table, so all those elements are electrically neutral. So why do you sometimes get shocked when you touch metal? Transferring charge. So some materials hold on to electrons more than others. Friction causes electrons to move. The accumulation of excess electric charges on an object is called static electricity. Conservation of charge. Law of conservation of charge states that charges cannot be created nor destroyed. They are only transferred from one object to the other. So if we go back to our previous slide, we have our shoes are rubbing on the carpet. We have all these positive and negative charges. They all build up. The negative charges will build up. They don't move very well through the rubber soles of your tennis shoes, but they can jump through your hand right here. Charges exert forces. So opposite charges attract. So positive and negative attract. Like charges repel. So positive and positive, negative and negative, they're going to repel each other. The force between the two charges decreases as the charges get further apart. So the closer they are, the stronger the forces. As they get forced apart, the force between them is less. So electric fields. Charges act at a distance. An electric field surrounds every charge. The arrow shows what would happen to a small positive test charge. So if we put a small positive test charge around this positive proton, it would move away. If we put one around this negative electron, it would move towards it. If we put a positive and negative together, you can see how the electric fields bend. They go out from the positive to the negative, and we can see these field lines right here. And if we put two like charges away, we're going to see their electric fields reflect each other and repel each other. So which is stronger, gravity or electricity? Defend your answer. Well, electrical, they both acts at a distance. So does gravitational. It acts at a distance. Electrical can be push or pull, and gravitational is pull only. Electrical is 10 to the 36 times stronger than gravity. Electrical is so much stronger than gravity. Gravity happens between all masses. It takes a whole world to hold me down. Most objects are electrically neutral. Gravitational, much smaller than electric. So that's comparing electric and gravitational forces. So what types of materials can electricity easily pass through? What types can it not? Well, conductors and insulators. Conductors are materials where electrons are able to move easily. The best conductors are metals. So insulators are materials where electrons cannot move easily. Plastics, wood, rubber, and glass are good insulators. So we have our wires here. Right here is our conductors, and they're surrounded in insulators to keep the charge inside the wire. So what causes lightning? Charging objects. Objects can be charged through direct contact. Friction can cause electrons to transfer. The object from which the electrons leave becomes positive. The objects where the electrons go becomes negative. So this kid sliding down the slide is picking up tons of electrons. Electrons all build up, and it causes his hair to stand up because they're reaching out to the positive atoms in the air. And so the slide becomes more positive because electrons go to the kid. The kid becomes more negative because electrons go to him. Electrons are negative. So objects can be charged from a distance. Charges act at a distance. So a buildup of negative charges on an object can repel the negative charges in another object, leaving it positively charged. This is called charging by induction. So we saw charging by contact when you rub your shoes in the carpet. This is charging by induction. So right here, if we have a buildup of negative charges, it'll cause the negative charges in the ground to move away, and we'll have lightning strike. Lightning can also strike upwards. So in lightning, friction in clouds causes electrons to mass. They build up in a center of negative charge. The negatively charged clouds induce a positive charge in the ground. So the negative electrons get pushed away. They move away, and they move away from the clouds. And lightning is caused when the negative charges jump to the positively charged ground. This is called static discharge. When lightning discharges, it heats up the air. The air temperature rises to several times that of the sun. The heat causes the air in the bolt's path to expand, producing the sound of thunder. And so these lightning strikes actually produce plasma in the air. Grounding. So discharge of static electricity can be damaging to many electrical components and living things. Providing a clear path to the earth prevents any buildup of electric charge. Connecting the path to the earth is called grounding. So here we have grounding on top of a building, lightning strikes. It's safely directed to the ground. We'll use grounding on plumbing stuff because the plumbing pipes go into the ground, so they'll often have a grounding wire go to plumbing stuff. So if there is excess charge, it's directed to the ground. And the ground acts as a great sink, and the charges can move away and dissipate in the ground. And that's it, guys. Have a great day. Thank you.